A restaurant owner anticipates serving about 180 people on a Friday evening and believes that about 20% of the patrons will order the chef's steak special. How many of those meals should he plan on serving in order to be pretty sure of having enough steaks on hand to meet the customer's demand? Justify your answer, including an explanation of what pretty sure means to you. All right, what's the first thing we should always do?
Find mean and standard deviation.
No.
Conditions.
Check the conditions. Okay, so is it random? Like, does it specifically say that it's random? No, but it's a representative sample. %10 condition. Do we meet that?
Yes.
Why?
Because
180 people is less than the entire population.
Of all the people that could potentially come in there, basically. So yes, 180 is less than 10%. All potential customers. Success, failure. How do we do that?
N times P greater than or equal to 10, and N times Q greater than or equal to 10.
Yep, so N times P would be 0.2 times 180. And N times Q would be 0.8 times 180. Do you know what the two numbers are?
The 0.2 times 180 is 36, and then the other one is 120.
And yes, both of those are greater than or equal to 10.
Just a little bit.
Just a little bit. So what does that mean? If all of our conditions have been met, what does that mean?
Normal model.
Yep. Normal model is appropriate. And so the normal model would be for, we know that the mean is 0.2. I don't have the standard deviation yet, so I'll have to come back to that. So how do I find the standard deviation of p hat?
Square root of
Square root of P times Q over N.
Yep. So square root of 0.2 times 0.8 divided by 180.
So we did meet the random condition.
Yes, because it's representative. Because it doesn't say that it's random, but we know that 180 people would be representative of the population. Because we don't know who's coming in. It's not like it's, golfer's night or something, that may or may not be random, but.
The standard deviation is 0.0298.
Okay, so 0.03. So I'm going to draw a curve. So the middle is 0.2. One standard deviation away would be 0.23. 2 would be 0.26. 3 would be 0.29. So what would we classify as the usual amount? Or where would we get to the point where we would say it's unusual?
To do standard deviations, so like 0.23.
Yep. So what we would do to find this is we would say we want it to be, there. So 0.26 times 180 And this is going to tell us how many steaks he should expect to need. Okay, so we can't have a 0.8 of a steak, so we're going to call it 47 steaks. So 47 steaks is 2 standard deviations above the mean. So it would be unusual to need more than that. So when it says how many of those meals should he plan on serving in order to be pretty sure of having enough steaks, pretty sure is basically just saying 2 standard deviations away. Like, as long as he's within that range, he should be fine. And at that point, they just say, oh, well. There's a place we go eat at in Gloucester, and they only make so much of each thing, like, each day. And one of them being their desserts, because obviously, like, everyone doesn't buy dessert because, you know.
Yeah.
So there's been, I think, one time out of the, like, 5 or 6 different times that we've gone that they've had this one dessert in that my mother-in-law likes. So it's like, they're like, you need to call so we can, like, hold one back for you. Or let us know you're coming. Like, so, anyways, because of this principle, they're, yeah.
What is it?
I don't honestly really know. It's like, I'm going to say it's like creme de la creme or something, but it's like,
Oh.
it's like fire, like,
Yeah.
roasted on top. I don't really know how to explain
Yeah,
it.
like meringue,
Anyways.
basically.
No, it's not. It's like custard, but it's
Oh,
really,
yeah.
really
That's
sweet.
wonderful.
Oh.
And, like, I had one bite of it, and I was like, yeah, I'm good. Like, she loved it, but, I mean, it's good, but it was too sweet for me. I was like, I'll take the pie. Like, but anyways, but that would, essentially, that's what they would be doing, is they would say, well, on a normal night or on a normal Friday night or whatever, I have this many people wanting dessert, so I need to prepare this many. And anyways, real life application for you. All right, in a special promotion bag of candy, Groovy M&Ms are supposed to make up 305 of the candies in the bag. In a large bag of 250, it's supposed to say 30%, not 305.
I was wondering.
I was like, something doesn't sound right about that. There needs to be a percentage in here
I
somewhere.
was like
I was.
305.
What? It's a bag.
Did we
of
count the
250?
number? Like,
Yeah, I was like, what's happening?
I
That
think
makes
the
a lot
percent
more
sign's
sense.
on the 5, so I probably just didn't it. Okay, in a large bag of 250 M&Ms, what is the probability that we get at least 25% Groovy candies? What do I do first?
Check conditions.
Check conditions. Is it random?
It doesn't say it is.
no, but it's a representative sample.
Yeah. Doesn't specify, but we can assume that a bag of M&Ms is going to be random. It's not like a bag of all reds. At that point, it's not very random anymore. Did you bring M&Ms today?
Yeah. I ate them in your class, I think.
Yeah, I thought so.
Yeah, I had the blue peanut butter ones.
Just blue?
No, but they
Oh.
exist.
Do you eat the
was it
peanut or peanut butter?
Both.
Okay. All right, 10% condition. Do we meet that?
Yes.
Yeah,
Because
I
would
don't
it be
think
250 is
Out
less
of
than
all
of
of the M&Ms in the world.
I mean, it's just one bag.
Exactly.
Yep. Success failure. So N times P would be 0.3 times 250. I wrote it backwards, so. I'll just write this one backwards for consistency's sake.
No, I assume it works out.
I got 75 for 0.3 times 250, and then I got 175.
well.
And so both of those are greater than or equal to 10, so we're good on that one. So, what does that mean?
We have a normal model.
Yay. For point 3 in, we haven't done standard deviation yet, so I'll come back to that. So, standard deviation of p hat,
So PQ over N.
just square root of
Square
point
root,
3 times 0.7 over 250.
.03.
0.03. So now, if I was going to, well, even though I'm not going to, but well, anyways. I need to do z-score. So z is equal to y bar. Okay, for y bar, it's this value here, the 25%, because it's for that particular problem. So 0.25 minus 0.3, so the 30% that would be our mu, over 0.03.
Negative 1.67.
So at this point, I would look at a picture of what I'm looking at, right? So I've got my mean here in the middle of 0.3, okay? And I want to know that there's at least 25%. So what do I need to do for that? Or what do I need to be thinking of for that?
25% in this one?
Yes. So 25% this way. So then if you were going to do it by hand, we could do the probability of z being greater than negative 1.67 from your table and get the answer that way. Or we could use the calculator function. Which one would we use? Normal CDF of negative 1.67, 1E99, 0, and 1. .95. So, to summarize that, according to the normal model, the probability the bag has at least 25% groovy M&Ms is about 95%. 4.95.